Alright, so Unit 1 of AFM. I'm ready, you're ready, let's go. First part is probability. It's Unit 1. It is found in the North Carolina Standard Course of Study. That's the big book of all the stuff I've got to teach you. The number for it is, of course, AFM, and it is 1.03. Today we're talking about part C of that. Okay, I know you don't care about that, but in case you do, there it is. So, the word of the day, and what we're going to be talking about is probability. Okay, and everything about it. So, I'm sure you've heard the word before. We're going to talk about what it actually means and how to use it. So, the definition of probability is simply the chance that something will happen. The chance that something will happen. Okay. So let's break down what that means. It's pretty self-explanatory. What's the chances that anything will happen? When you're talking about those chances, we're talking about probability. So when have you heard probability? When have you heard chances of something? Think about some examples. Maybe you've seen this little guy before. He looks like this. And beside it, it'll have this. Right? What am I talking about? There's a 40% chance of rain today. Okay? Chance of 40% chance of probability. Awesome. Or you'll see a big chart that looks like this. Okay? Or in reality, it looks like this. And it says this name down here. And it's his approval rating, right? And it's the probability he gets reelected. What's the chances that Obama gets reelected? It is a 35% chance. I'm just throwing it out there. I have no idea what it is. Okay, so that's another chance, another probability. Or going back to 7th and 8th grade, what is the chance that I pull a red marble out of this bag? I might have a 3 out of 10 chance. Okay, some simple examples. Probability, chances. Chance, chance, chance. That's the key word. So, okay, within those examples I just gave you, we had rain, 40% chance of rain. We had approval rating, 35% chance he gets reelected. And then we had our marbles, and I had a 3 out of 10 chance. Okay? So within those 3 examples, let's talk about 2 ways that we display probability. And I know a lot of this you should know, and that's okay. If you want to fast forward me, don't. Haha. So I talk about probability 2 ways. I talk about it as a percentage, which will be the main one, and then if we talk about some old school stuff, we'll talk about a fraction. You should know and you should remember that these are actually the same thing. Fractions and percentages are the exact same thing. To turn this into a percent, I do 3 divided by 10, and I will get 0.33, repeating. I move my decimal over 2 places, and now my new percent would be 33%. So all of this is percentages are our ways of communicating chance. So we communicate chance or probability is communicated by percentages. So, and I should have put this beside probability when I first started, but I didn't. I should have told you this in advance before this video, hopefully I did, that I will try to star things that can be made into note cards, because you know that's one of your activities you can do through the week. So this one would say probability or chance is communicated through percentages. You want me to write that? I will. Probability is communicated using percentages. Probability is communicated using percentages. Beautiful. Alright. If you didn't get it, pause it, write it down. Great. So now we know how to communicate probability. Now we're going to do it and put it in action. One of the simplest experiments or things we talk about probability is, you know, what are the chances of me getting heads or tails when I flip a coin. And that's what we're going to work with. So I'm going to pull out a coin. Trusty old penny. Okay. I'm going to flip that penny in a minute. But we're going to talk about two types of probability. There's theoretical probability. Oh, stretching. Theoretical probability. And that theoretical probability is the, let me tell you exactly what it says, is what you expect to happen. What you expect to happen is theoretical probability. Write that down and I'll explain in a second. Experimental probability, that's not the same type of star. There you go. Experimental probability. I'm going to do that every time. Probability is what actually happens. Okay? So think about this for a second. Theoretical probability. What is the theoretical probability of me flipping heads on a coin? What are the chances of me flipping heads? I have two options. Heads is one of them. So I have a 1 in 2. Right here. 1 in 2. Or, how to turn it into percent. 1 divided by 2 is 0.5. Move my decimal over 2 places. Add 0, and I get 50%. Okay? So, 50% chance I get heads. Now, if I flip a coin 1,000 times, I should get it 500 times. That isn't always the case. So, the theoretical is my 50%. The experimental is if I flipped it that many times, what I actually get. And we're going to do that right now. But not 1,000. Don't worry. So, the theoretical probability. Okay. Let's say I flip this coin 10 times. If I flip it 10 times and I have a 1 in 2 chance of getting heads, how many heads should I get if I flip it 10 times? 5. So you have 5 heads, 5 tails. Doesn't matter the order I write them, I should still get them because I can't really guess the order. So let's say I get a head, then a tails, then a head, then a tails. Then a head, then a tails, then a head, then a tails, then a head, then a tails. Okay? So in total I got 5 heads and 5 tails. That would be the theoretical. That's in a perfect world where I flip it the same every single time and there's no gunk on my penny and everything worked perfectly, I will get 5 and 5. That's what should happen. Now, the experimental probability is a little different. It's what I actually get. So I'm going to flip this coin 10 times. So first time I get tails. Okay. Tails. Tails. Wow. Tails. I Promise it's not a double-sided coin. Heads. Heads. Wow. Tails. Heads. Two more. Heads. Tails. Okay, so I got 1, 2, 3, 4 heads, and 1, 2, 3, 4, 5, 6 tails. Okay, so as you can see, my phone's about to die. As you can see, there is a difference. Theoretical was what I should have got was 5 and 5, but my experimental actually got 4 and 6. That does not disprove my theoretical. It doesn't change it. It doesn't make, oh, well, we were wrong. It should have been 4 and 6. No, it's just two completely separate things. Even though it was the same problem, same idea, they're still two separate things. And tomorrow we're going to do some activities. You're going to make your own kind of scenarios without pennies. You're going to figure out stuff on your own, find stuff in the real world, and we're going to do this some more. So, hope you got it. Write down the notes. It should have been 4 stars. Yes, 4 stars in this, so that's 4 note cards. Alright, see you tomorrow.